Why is closed-loop control robust against unknown disturbances? Imagine you're steering a boat across a river, trying to stay on course. If a sudden gust of wind pushes you off track, you adjust your steering to stay on course. That's similar to how closed-loop control systems work. They keep things steady even when surprises happen. In electrical engineering, a closed-loop control system has four main parts: a controller, the system to be controlled, sensors, and a feedback path. The sensors measure the output and send that information back to the controller. The controller compares this output to the desired goal, called the set point. If there's a difference, called the error, the controller adjusts the input to fix it. This continuous checking and adjusting process is what makes closed-loop systems strong against unknown disturbances. When something unexpected happens, like noise or a sudden load change, the sensors detect the change in output. The feedback loop then tells the controller about this deviation. The controller responds by changing the input to counteract the disturbance. Because the system keeps correcting itself, it doesn't get thrown off by external surprises. For example, if a motor is loaded more heavily than usual, the feedback detects the slower speed and commands the motor to work harder. This keeps the motor running at the right speed despite the extra load. In contrast, open-loop systems don't have this feedback. They set the control input once and don't check if the output is correct. So, if something changes unexpectedly, they can't fix it. That makes open-loop systems more vulnerable to disturbances. From a control system's point of view, the key reasons closed-loop control is robust are error detection and correction, reduced sensitivity to parameter changes, and the ability to stay stable even when conditions shift. The feedback loop acts like a safety net, catching disturbances and automatically adjusting to keep everything running smoothly. In real-world electrical engineering, closed-loop control is used everywhere. Power supplies, motor drives, and communication systems all relying on it to keep performance steady despite noise, load variations, or aging parts. Designing these systems well means tuning the controller carefully. Too much gain or delays in the feedback can cause oscillations or instability. But when done right, the system can handle a wide range of unknown disturbances without losing control. So, the main reason closed-loop control systems are tough against unknown disturbances is because they constantly sense output deviations and automatically correct them. This feedback loop makes sure the system stays on track, no matter what surprises come along. It's like having a built-in safety feature that keeps everything working smoothly, even in unpredictable environments.